we now want to talk about, well, supply chain, AI, and data that makes our key differentiator. So a topic that I'm sure you have been hearing about already today. However, we want to start where Enrico left off this morning. During his keynote, he was talking about supply chain digitization at Amazon. And we want to start from that point, from a perspective of what can you adopt from the way Amazon is working with operational data and how we use AI and analytics. Secondly, we then want to talk through how we scale innovation. So we heard about some topics around AI as a tool. We also heard about working backwards, starting small. And we want to also spend some time talking about the concept of primitives. Then we bring that to AWS, so Amazon Web Services, the cloud services that we provide, and how you can actually implement AI use cases in supply chain today. So I will probably go over those very first slides fairly quickly, since this, to me, pretty much goes with the same theme that you've been hearing about already. We have today's supply chains. They are complex. There's a high degree of velocity, and there have been ongoing disruptions in recent years. I would add one thing to that, which is there has been also an increase in customer expectations. So the expectation to be able to serve a large catalog of products, the ability to serve consistently within a very short period of time and get the package to the customer doorstep, also those types of expectations are increasing. And we have to make sure that we can meet them and improve on them every day. However, this is often not what we can spend our time on, right? So there is day-to-day challenges, there are disruptions, and we need to figure out how we can get up and running again, how we can get it going, how we can solve those problems. And there's a variety of reasons why that is happening. And the point here is some of them are under our control, like fragmented data, different systems. Some are outside of our control, and some are physical in the area of congested ports, stock out, and the like. So I stole that quote from Lobster saying, AI won't fix your supply chain, right? So AI doesn't come to the rescue, and suddenly all of those problems that we've been hearing about today in our sessions are gone. Doesn't happen. But it's a very interesting tool, and it works really well when we can combine it with our data. And that's what we're going to explore today further. So I brought a very long video. It's over, yeah? But this is an Amazon fulfillment center. So how many of you have been potentially to an Amazon fulfillment center in the past? Maybe you can raise your hand. OK, we actually have a raised hand. We have a couple of raised hands here. I was expecting that. So what you see here is our storage area. So this is where we have our shelves, which you can see here in yellow. We have our robots, which are bringing the inventory that we store to the fulfillment center employees who actually work on customer orders. And this entire system is heavily based on data collection, data analysis, and using algorithms and AI to assist in the individual steps along the journey of the package through the FC and then to our delivery to the customer. This slide we usually show to explain, well, what is Amazon now doing in terms of various stages of supply chain digitalization. I would like to point out what are the main things, what are the main themes of this that you can take and adopt. And this starts with the Amazon promise. How many of you have heard of the Amazon promise? And here I would expect pretty much everyone to raise their hands because Enrico was covering that as part of his presentation. So the promise is what we give to a customer when you make an order on Amazon. We tell you, hey, it will be at your doorstep at this time when you order it in the next 2 hours and 22 minutes or something. And we can do that based on holistic data collection throughout our operations. So that is, I would say, the first takeaway. We need to understand what is our inventory. We need to track and trace, so we understand where is the product in our facility. When we have ordered replenishment of goods, we need to know where that replenishment is and what the ETA is when it is about to arrive. And the closer we can get to that picture into our data, the better we can give a highly accurate promise to the customer. The second point that we can do when we have that is simulation. So for us at Amazon, we have our peak season in the fourth quarter every year. And that means we can expect like 50 to 70% increase of throughput in terms of customer orders on the network. So where does the network break, right? Where's the bottleneck where things don't go smoothly? Because we have that, you could say, digital twin of the operations, we can actually simulate how that twin behaves. So moving from a monitoring digital twin, which represents the current state, to a simulation twin where we make adjustments and see how it works out. And that allows us to prepare as good as possible for those high-scale, high-throughput events. Then on the fourth one, you see Amazon Perfect Mile. This is bringing all of those data flows together to inspect root causes. Like when we don't meet the customer promise, when things go wrong, the package is, we deliver the wrong thing, or doesn't arrive, or it was like the app says the product was delivered, but it's not actually there. So something didn't go right. In this case, Perfect Mile is the system that breaks all of the traceability data down for that customer order and then derives a recommendation as to what has happened. And we need that because that is then again the basis for continuous improvement cycles. You have to look at, okay, how can we prevent that? That has happened 1,000 times in the last year. How can we change that? What different mechanism could we use here? And this then informs also in the automation robotics space, what areas should we invest on? So when we focus on developing our own robot for a specific task, when we focus on a technical solution, we work backwards, connecting this to what Enrico has said. We work backwards from a problem that we can see in our data. And besides knowing that this will then actually solve something meaningful, this also helps us quantify the problem. So if something happens 10 times, it's probably less important to fix it when it happens 1,000, 10,000 times or more. And then, of course, lastly, as also Lobster put directly in the first keynote this morning, the value of end-to-end collaboration. So not just having that visibility internally, but actually having mechanisms to exchange information with trading partners, logistics providers, customers, and so on. And you can see that actually we did not even talk about AI yet. So everything we covered was just really the underlying data foundation that we put in place. Collecting everything internally, getting to a point where we can simulate the operations, getting to a point where we can inspect root causes when things go wrong, and then extending that to collaboration with trading partners left and right. On top of that, we then use the actual algorithmic optimization, AI, and the like. And I want to talk about a couple examples, especially since I feel when we talk about generative AI, about agents, a lot of the time, the discussion, we think about chatbot. So I have an application, I give it some text, and it gives me a response. Or it even performs some actions and then gives me a response. Why I like this slide a lot is because it also shows there are other so-called modalities beyond text, images, and voice. And the first one is what we call Project Wellspring. There, the idea is to work with geospatial data, so satellite imagery, map data, routing information. In this case, Project Wellspring was focused at identifying the best delivery location for packages in really complex delivery areas. So let's say we have like a large city, and there's a large apartment complex, and we need to find the perfect positions where our truck can park to actually bring the package to the doorstep of the customer. This is, for us, actually a meaningful problem. So we can use generative AI, but not with text, but with geospatial data to figure out where do we need to park to minimize the time we need to bring the package to the doorstep. And actually, just yesterday, I saw that a team of ours, we released an open source implementation for using agentic AI with geospatial data. So this is also a use case. If this is interesting, we have references that you can use as a starting point to adopt. The same goes for the second one, demand forecasting. Also a generative AI case, which is also not about data, but about time series. So when we do a demand forecast, we traditionally use things like linear regression to understand, this is our past sales history. How does this evolve in the future? And our Amazon Science team has built models called Kronos. And end of last year, we launched the latest one, which is called Kronos 2. And Kronos 2 takes your time series input and based on that generates how this time series supposedly continues. And in Amazon's case, this has worked really well with a 10% forecast improvement on nationwide sales, 20% for high-frequency popular products, and 10 and 20% respectively is, of course, a significant improvement in terms of accuracy. Third one, which is interesting, is this area of today called physical AI. So can we take a physical device and teach it not just in the past, we had robots who got programs. Yeah? So the robot got a very specific set of instructions as to what it should do. Like in motion control, right? The robot could use specific movements, could use specific tools. The idea with physical AI is, can we teach a robot to understand human language? And in the case of our Proteus robots, which you can see on the screen, use visual language models to understand surroundings. So I don't program deterministically what the robot is supposed to be doing, but I tell it. I can say, hey, go there, grab the yellow package, and bring it over here. And the robot doesn't need a program to do that, but it understands the human intent and can support that. All of these solve very specific problems. The first one helps get the package out of the van to the doorstep faster. The second improves our demand forecast. And the third one allows us to better use robotics in the facility. So this is what we consider primitives. So it is not the AI suddenly runs all of the operations because someone clicks on the AI button. But we have a very specific problem. We figure out what is the right level of considering a solution in terms of abstraction level for this problem. This is a primitive. And then we scale this primitive internally. Because it's also, when operating at a larger scale, you don't have, and I mean, don't need to tell this to anyone, we don't have the holistic, nice systems everywhere, all of the data is connected and integrated, but we have site-specific requirements. We have process-specific requirements. And this is the power of primitives, that we can provide a piece of technology in a way that is easily scalable to different use cases. And this is also where AWS originally came from. So this strategic principle around when we think about technology, we think of primitives and how we can scale them. This comes from, I think, the early 2000s in the Amazon history. And by 2006, we had a number of those primitives where we said, OK, actually, those are pieces of technology which can be quite interesting to other companies. And this is how we launched AWS. And what you see here on screen is a map of the so-called AWS global infrastructure. So our network backbone, our various data center regions that we have around the world, 39 these days with 123 availability zones. One zone is one or more physical data centers. And we have 240 plus of those primitives, of those building blocks, who make up our service landscape today. And one thing I want to point out here is what you see on the bottom right, which is our partners, and especially collaboration with companies also like Lobster. Because even when you have 240 primitives, it doesn't mean those can solve all of the problems, right? So we believe AWS is quite good in the area of cloud computing, but there are domain-specific areas where you need the industry expertise, where you need the expertise about specific business solutions involved. And this is where we heavily focus on working with others who bring that expertise to the end customer. I actually want to talk about this slide first, which is now talking some more about supply chain use cases in AI that we do with with AWS with customers. Because we didn't want to put like a lot of product names into this presentation, so we rather talk about here's some piece of technology that really works quite well. First one is identifying patterns. So we spent a lot of time today talking about we have to get the underlying data foundation right. And an immediate follow-up thing that we want to be able to do when we have the data from different systems brought together is figure out whether this data is logically sound, whether it makes sense. And AI models are actually not just good at predicting the next word in a sentence, which is how, for example, when you use ChatGPT, a response is being generated. It also is pretty good at predicting when something is not what it would expect in terms of statistics, in terms of probability. And that makes those models quite good at telling, hey, there's something wrong with this data. Where a human can get overwhelmed at some point where there's just so many different sources of information, we can use AI to more easily run root cause inspection and find anomalous patterns. The second one I also find interesting, and we also had this earlier today in the morning. Many problems in supply chain are optimization problems. So we have constraints, we have available shipment capacity, we have dangerous goods that we need to bring from A to B, and the like. And we have to find the optimal solution. So for example, in how much inventory do we hold, how much do we manufacture, to which warehouses do we bring those products. Those are optimization problems, which are also not just a one-click replication by sending the AI instead, right? But what can be very interesting is using a large language model and generative AI to give easier access to the regular human to use those optimization algorithms. So the operator can say, hey, machine 5 just broke down. Give me an updated schedule for this manufacturing shift. And AI can still use the traditional mathematical operations research algorithms, but the human is not the one who has to understand that in depth and be able to formulate that problem mathematically, but can just tell what to do and then get a response in human language. And when bringing that to the AI, I would say, time scale, I also want to talk a little bit about different terminology that we've been using today. When we originally started with these generative AI interaction capabilities and then the use cases that I've now been covering, this was in the area of generative AI assistance. An assistant to which I can bring a question, to which I can bring an image, input text, and then I get a response. Over time, this has been augmented by bringing my own knowledge. So there is a pattern, which some of you may have heard, called retrieval augmented generation, which means we bring our data to the model, and the model can make business-specific assumptions, can get a business-specific understanding for us. That has been moving into generative AI agents, which means we cannot just bring our business context, but we can actually also bring the capability to perform simple actions. And today, we are actually on the right side, which is agentic AI systems. And this means that we can use, and I'm sure some of you who in the room has heard of the MCP protocol, Model Context Protocol. OK, that's half the room. That's quite good. So MCP was built by a company, Anthropic, and released, I think, late 24, early 25. And the idea is to have a uniform standard to make a resource, a piece of knowledge, an action to be triggered in a system available to an AI so it can easily understand how it can do with that resource, with that knowledge, with that tool. And that helps us build quite complex workflows these days, because also the model providers who build AI models have been specifically optimizing those models to understand sequences of instructions, where I can now say, hey, please, or you can leave out the please, yeah, that saves you a bit of text. You can say, hey, here's a process, optimize it for me. And then the model can use protocols like MCP to understand what is available to me, to understand what the human wants, break that down in a sequence of 5, 6, 7, 10 steps, and then execute on them with a high probability of getting things done surprisingly well. Of course, you see I'm skipping a slide here. That, again, only works well when you have the data and tools to make that possible. So let's move towards the later part of the presentation by just talking about when we talk agent systems, when we talk agentic AI systems and capabilities, what makes such a system? Well, at the center, you see what we've just been covering. We see the large language model. And this is the model, we discussed it, it's optimized to understand human intent, break it down into a sequence of tasks, and then execute on those tasks. Where do those tasks come from? Those come from the tools. Yeah? So the tool is what we've also been covering, is, for example, using MCP to understand this is how I talk to my ERP system. This is how I trigger a purchase order. This is how I initiate replenishment of a specific material. This is how I communicate with a supplier. All of that can be exposed as tools when we have the right underlying data infrastructure through which we can make that available to the model. And then we combine this with other areas like memory. Memory is very interesting with agents because that allows the agent to remember what it did in the past. So effectively, it can learn. You can use a workflow, run it, and the agent comes up with a result which is just complete garbage. But then you can explain it. You can say, hey, this answer was wrong, and this is the reason. You picked the wrong tool in step 5. And I would have expected, by the way, that in step 7, you passed this information piece to the system, but you didn't, and that's why it didn't find something. Yeah? So you can explain that. What can the agent do? It can store that in memory. And the next time it runs the same workflow, it knows it. Yeah? It remembers, it retrieves the memory, and then it works. And this is the interesting learning nature of those systems with today's agent architecture, where it gets better and better over time, and you can pass, as a human, your personal feedback explaining how it can do better in the future. And all of that, to close, on the right, we then also want to have observability into. Observability means, from a interaction perspective, so the screen that you see on the right, the user still gives an instruction and then a couple seconds, couple minutes later gets an output. And sometimes this is incorrect. And in observability and guardrail scenarios, which we also want to have with agents, is we can understand what was the detailed decision-making process that took place behind the scenes. So this is when in traditional IT systems where we want to have metrics, where we want to have system logs that tell us why our system crashed at Sunday night, 3 a.m. The same goes for agents. We want to have this protocol of everything that it did to respond to a user interaction. On AWS side, we do have services for both the centerpiece, which is the model provider. So we also have a partnership strategy there, where we work with various model provider companies. I think so I'm based in Germany, in the Frankfurt AWS region. We have today 200-something different models that we expose through that. And then we have also the surrounding stuff that we have on the picture. For us, is more of the tooling workbench, for which we also have a service which really helps you integrate memory in an easy fashion, integrate the observability. And all of this is targeted at the end to build agents which come up with high-quality outcomes. Now, I want to close with some final use cases around the supply chain space. But all of those, this is one point I want to emphasize again, heavily benefit from interoperability. So when you design those systems, keeping in mind that we want to be flexible as to what data we introduce to the system further, again, something that Lobster, with a platform as what they provide, makes fairly easy to bring that together into a uniform data layer. But also when we then combine this with analytics tools to use standards in terms of the data structure, so something emerging there, what you see on the slide is the Apache Iceberg format for table structures, for example. We already talked about MCP in the center to standardize the agent interaction with the data and the tools. And then on the right side, interoperability. Well, this is more of a broader industry idea, yeah? Using EDI, electronic data interchange, using applicable standards where they are available. So I work, for example, a lot with manufacturing customers, including in an environmental and reporting space, where at least we do have standards these days as to how an environmental product declaration looks like, how a data set looks like that describes the impact of a product component that we are manufacturing. And using those standards where they are available really helps you build interoperable solutions in the sense that you can reuse that data easily across different use cases, and you store data in a way that is easily relevant for customers, for example, for partners, when you go into an in-company interchange scenario. So this is a summary slide. Yeah? Some of these are AI use cases. Some of these are analytics use cases. Some of these are Gen AI use cases. Those are all areas that we have customers on that we have been implementing this with. So when any of these is of interest, we can also share more in case you want to visit our booth as to what exactly was the problem, what have we done there. The key message here is that those are very different types of AI problems that you can see. We have the predictive maintenance, which really uses often classical machine learning, regression, understanding when, based on sensor data, a part is going to break. We have customer experience, which often is a generative AI type of problem, where we can look into AI-supported chatbots or call center, like using AI voice capabilities. And then we have route planning optimization, which goes into this operations research, constraint programming, linear programming, so really mathematical optimization problems based on which we define what is the ideal situation that solves our problem. I just want to bring one example on the ladder, which is that we have a science team just for optimization problems with customers. And as part of that, there is, for example, one solution for which we've built a reference implementation as well about route optimization and dispatching. And this goes into exactly that mathematical category of problem, where we have different system constraints saying, OK, this is the rules that we have to meet. This is the objective function. So we optimize for cost. We want to optimize for time. We want to optimize for material or waste reduction. And this helps us, at the end, build a mathematical model that gives us the right results. Also an area that we are happy to talk more about in case you're interested. So getting from all of those examples back to the original slide that I showed at the beginning. In Amazon, we do use all of those approaches that we've now covered along different steps. To connect this back to our earlier presentation, all of those are individual primitives that support a very particular problem. And in case we can validate the value, we make it available internally for easy scale and for adoption by other engineers, by other groups, so we can effectively bring it to the breadth of the company. And the last thing is, now you see me getting off track here a little bit. Yeah? The last thing is that we also have, in addition to the routing part, we can also talk about warehouse management, optimization. We have some command center capabilities in supply chain. At the end, I would recommend let's have a discussion when you're interested to follow up on those. I also tried to draw a bit of an arrow, yeah, because our booth is effectively over there. I hope the arrow indicator is the right one. And thank you very much for being here. I hope you learned something about the very different types of use cases where we can apply AI in practice today, where it works well. And we also brought, same as Enrico earlier, a small survey. If you want to share feedback, if you want us to stay in touch, to follow up, let me know. Thank you so much.